And a lot of this stuff is going to be non-calculator, just so you guys know. When we're graphing simple rational functions, we're going to look at the following scenario. Rational function is basically some polynomial divided by a polynomial. It's just polynomial over polynomial is the way this is going to work. And each of these types of graphs have certain characteristics. We're going to be able to find intercepts, asymptotes, both horizontal and vertical. And we're going to see how we're able to plot points by just using values that make sense. Values that you're going to be able to do in your head when you're working with fractions and things like that. It's actually not as terrible as it probably start to look. So, example. Y equals 1 over x. Before I even bother with graph paper. If you wanted to graph y equals 1 over x, when you first learned to graph, what did you guys always do?
Make a table.
You would make a table.
Find 0.
When you guys would make a table, a lot of these things you'd start out with -2, -1, 0, 1s, and 2s. You agree? Okay. And you would just substitute in. So you'd substitute in, you get -1/2, -1. What happens when you divide by 0? Can't do it, so what is it?
0. Not a number.
No. No.
It's not plausible.
It's undefined.
4.
It's not the same as 0. It's an asymptote.
Okay.
You got there.
Okay. It's 0 of the denominator. Zeros of the denominators are always the asymptotes, the vertical asymptotes. You have 1 and 1/2 again. What's that? I can't spell asymptote at the same time. I can't. Asymptote. Is that right? Asymptote. So when we go to graph this then, things you got to plot, we have that vertical asymptote at 0. So a lot of times I just kind of overwrite that I have a dotted line there. I think we've done this before. When we graph stuff, let's say you made that solid line and you forgot to make it dotted, you could always just put an arrow and just say it's dotted.
Yeah.
You know what I mean? Because if it's on the axis, it's kind of tough to draw it being dotted there. So if you ever, when you label that, if you want to do this and just say dotted, because it's vertical asymptote. Because can you divide by 0? It's undefined. So that's one of the things that happens a lot in this first 9-2. Put your phone away. Texting doesn't help you do graphs. So put your phone away. No, put it in your pocket so you don't flip it over and look at it again in like 5 seconds.
It is not secure.
Well, then put it in your locker. I know, I'm a jerk.
I think you're a jerk.
So as you go through this, it's just a matter of plotting some values. Now what I want you to see, at -2, it was at a -1/2. At -1, it was -1. Asymptote, 1, 1, and then it was 2.5 again. This really isn't a good idea, to know what the curves or are doing to this, unless we pick out a couple extra points. So let's add another one. Let's add a 3, a -3. Let's also add -1/2 and +1/2. Okay? The 3 and the -3 are pretty easy. You get 1/3 and -1/3 respectively. But what happens when you divide by a fraction? Multiply it by its reciprocal. So what's 1 divided by a half? 2. So 1 divided by a negative half would be negative 2. So now you should start to see what's really happening in the curve. At negative 1/2, it's at 2. At positive 1/2, it's at here. At 3, it's at a third. And negative third. So your curve itself is doing this. You have a double-sided parabola. It's reflected over that y-axis like that. It's actually reflected over a slant asymptote, but we'll get to that stuff later. All right, we'll get to those later. So you get stuff like looks like this, and these are parabolas that are on both sides. Excuse me. Let me show you another example. As we get into these things, did I say a parabola or hyperbola? Sorry. So when we have these hyperbolas, you get these couple little properties that we're going to work with. And the x-axis is going to be a horizontal asymptote to start with. The y-axis is going to be the vertical asymptote to start with. This graph is because you had this, 1 over x, as your equation. When you have 1 over x, you can't divide by 0. If you divide by 0, bad things happen. Bless you. You wind up with that vertical asymptote. As things start to get smaller and smaller, larger and larger and larger, 100, 1 million, 1 gazillion, 1 quintillion, and so on, it's getting closer and closer and closer to 0. But will it ever reach 0? No. So you also have this horizontal asymptote at y equals 0, as well as a vertical asymptote at x equals 0. Excuse me. Your domain is all real numbers except 0. Remember, your domain is restricted by the vertical asymptote. Your vertical asymptote is always your domain restriction. Your range restriction will be everything that's not a horizontal asymptote. So your domain and range are both restricted by 0. And you'll notice that you have that reflection, the corresponding points negative x, negative y. They just flip themselves around. Okay. Now, what we do with this is that we take this very, very simple idea, y over x, and we'll write it as 4 over x, or 3 over 2x, things like that. And we're going to wind up graphing, just doing the same idea, picking points, plotting it, and making sense of fractions. Now, if you have to work with fractions, you have to remember what simplifies, your 3s, your 4s, things like that. And as you start to play around with these, you'll start to see that it really is, a lot of it comes back to your mind pretty quick. All right. So let me show you the other type. We have this A, H, and K version of this as well, where all of our, what do you think the H and K's are going to stand for?
X and Y.
Horizontal and vertical shifts to that standard idea of 1 over x. What? You never heard that? Vertical? That's why it's a K?
Oh.
I didn't know.
Horizontal, H, vertical, okay?
Coal.
Coal with the K.
What?
Did you just think I had like a tick?
Like something in your throat.
It's verklempt. That's how you remember it. Horizontal for H, vertical for K. I know it's the dumbest thing in the world, but you'll never forget it. Seriously. And I know you don't spell vertical with a K. I do know that.
Are you sure?
Pretty sure.
How do you spell alphabet?
We know you're not good at spelling.
How do you spell alphabet?
A-L-P-H-A-B-E-T.
Oh, I don't know either.
Because I had breakfast.
I can
Oh!
Shots fired. I had shredded wheat this morning.
Have you had alphabet cereal before? Do they still make that?
No.
You guys didn't know there was
I've had
alphabet? Have you ever had that before?
No.
Alphabet cereal was a cereal. It's kind of like, it was a little more of a frosted version of Cheerios. I mean, it was more like the cereal parts in Lucky Charms.
Yeah.
It was that.
The
It tasted-
worst part.
Well, no, the regular part. You're right. I just want marshmallows.
Yeah.
It would taste like that, but they were alphabet. They were just the alphabet.
That's kind of cool.
Was there marshmallows?
You said it wrong.
Exclamation.
So here's what happens. We're gonna have now asymptotes. You're gonna have your vertical asymptotes at the x equals h. Your horizontal asymptotes will be at the y equals k. But I want you to notice that it's your generic formula, y equals a over x minus h plus k. So if it's x plus 3, what's your h value? -3, and so on. Just the little ideas like that. Now if it's plus 4, it's just plus 4 for the k, because the k value is a positive one tacked on. I will tell you one thing. A lot of times this book puts the k value in front of the fraction. Why? I don't know. It just happens pretty often. So don't be surprised if you see the k before the fraction, or sometimes k behind the fraction.
What does your X symbol look like? Just a swirly?
It looks like
I don't know. This is how it's taught.
When you just draw
Math.
When you draw an A, circle it.
Just draw it like that.
I thought it was just like a squiggle.
Hey, I'm only, it says vertical, so I mean, I can do this too. So when we do these things, what I want you guys to do is always get in the habit of labeling right off the bat what your A, H, and K values are. Once you know what your A, H, and K values are, you can start to get the idea of where your asymptotes would be placed. Okay. So if I'm starting with the equation y equals, let's see, -2 over x plus 3, all subtract 1, I have an A value of -2, I have an H value of -3, and I have a K value of -1. With that information itself, I can go ahead, oops.
There you go.
I'd get it right eventually. With this information alone, I can start the idea of a sketch of what the graph is going to look like. All right. My vertical asymptote is going to be at x equals h. So what's my h value? -3. So I have a vertical asymptote at -3. I have a horizontal asymptote at -1. So now I got to figure out what's happening to this curve on both sides of these asymptotes. So I pick easy numbers to work with. For example, if I pick -2, if I choose -2 as my next value, I get -2 plus 3. What's -2 plus 3? 1. What's -2 divided by 1?
2.
-2. Because it's -2 plus 3 is 1. -2 divided by 1. So you get -1, -2. We'll get it right eventually. -2 minus 1 is? -3. So at -2, it's at -3. Okay. I check the next easy number. -1. What's -1 plus 3? 2. What's -2 divided by 2? What's -1 minus 1? So right off the bat, I knew that this point increased, which means it's probably doing this. Because one way that you can probably go a step further is if I use 0, I get -2/3. -2/3 minus 1 would be -1 2/3. So it's still smaller than -2. I mean, bigger. So, excuse me, bigger than -2 moved up. So it's moving in this direction, which means the other one should be mirrored on the opposite side. So we just got to check the next couple of values. So I check it at -4. Okay, and I walk through it again. -4 plus 3 is -1. -2 divided by -1 is 2. 2 minus 1 is
One.
1. Go to -5. -5 plus 3 is -2 divided by -2. +1. 1 minus 1 is? So it's doing this. Now, what I'm going to ask that you guys do is label your ordered pairs. All right? You gotta use your ordered pairs. Now, I know you can put this right in the y equals function of the calculator. You can press the table, and it'll spit them all out for you, which means you don't get a calculator for this stuff. You have to be able to work with numbers in your head and write them out. You gotta be able to do this. So we knew we had them at, was that -5 and 0, -4 and 1. This one was -2, -3. The other one was -1, -2, I believe. Okay. And we knew where our asymptotes were at. We knew we had a vertical asymptote at x equals -3. We had a horizontal asymptote at y equals -1. Those are the type of things you guys would be able to do. Not too terrible.
No.
A, H, and K, just a matter of labeling out what you know. All right? And just walk through it slowly. Pick numbers that you can do in your head. Yes, ma'am?
How many order pairs?
Usually all you need are 2 on both sides because you'll be able to see which way the curve's going if you do it right. A lot of times what will happen is if you try to do this and you do it wrong, let's say you miss a sign, this will jump to the other direction. You know you can't cross the asymptote, so you'll be able to see how it goes. That. So let's try a different version of it. There's another version of this as well that doesn't have that A, H, and K thrown in there. It's when it looks like this. We have a rational function that looks like y equals ax plus b over cx. Basically what this is saying here is you've got like a y equals mx plus b divided by a y equals mx plus b. That's what it means here. You've got 2 linear parts where your 2 polynomials are linear equations. Okay. And what happens here is that the reason that this is going to work, we're going to spend a little bit more time on this tomorrow, is that the degree of both of those values is 1. So you wind up with a horizontal asymptote at the fractional amount of the coefficients. Okay. It works out really, really easy to set up. You still have to deal with your vertical asymptote at the 0 of the denominator. So if you have, for example, 3x, so y equals 3x minus 2 over 2x plus 1. If I do something like that, besides playing on my phone, thanks. You guys gotta stop playing on the phones, seriously. You have to believe me that the grades. See how you have this here, you've got your degrees are exactly the same. When this pulls out like this, where you wind up with it looking like that, well, your horizontal asymptote is gonna be at y equals 3 over 2. Your vertical asymptote is still at the 0 of the denominator. It will be at x equals what?
-2. So,
-1/2. Okay.
wait, what's the?
Why is it -1/2?
0 of the denominator. Set it equal to 0 and solve for x. Subtract 1, divide by 2. Okay. Every time, no matter what, your vertical asymptote will always, always, always be the 0 of a denominator, no matter what kind of function it winds up being, guys. Whether it's these rationals, radicals, we do those later on, trigonometric, it's still going to be that whatever gives you 0 in the denominator. You'll see that a lot in trig when we do graphs of tangent. What do you mean flip them around? What's the 0 of the denominator? Set 2x plus 1 equals 0. Solve for x. subtract 1, divide by 2. That's what I was doing. I was just doing that real fast. Okay. So this is what it would look like. And then as far as graphing it, as far as graphing something like this, well, vertical asymptote at -0.5. Horizontal asymptote at 1.5. And then it's just a matter of picking values. To be honest with you, the easiest one to start with would be at 0.
Okay.
Because what's 3 times 0? 0. What's 2 times 0? 0. So what's -2 divided by 1? Go to 1. What's 3 times 1? What's 3 minus 2? 1. Okay, so it's 1 in the numerator. What's 2 times 1? What's 2 plus 1? So if it's at 1, it's 1/3. And you can probably tell right off the bat by this increasing to this direction that the curve is going like this. Okay. If you go to -1, you get -3 minus 2 gives you -5. Then you have -2 plus 1, which is 5. So at -1, it was up here at 5. And try it at 2. -2, excuse me. If I do it at -2, you get 3 times -2, which is -6 minus 2 is -8. Then I have -4 plus 1, which is 8/3. 8/3 is 2 2/3.
I think so.
So it's coming over this way. Let's do the same kind of idea. Did I use any decimals?
You do not.
Correct. Okay. Just little things like that. That's just basically what you're working at. You start plotting your asymptotes, you just pick values near to the asymptotes. It's usually the next couple of numbers on either side of your vertical asymptote will give you the reflections that you're looking for. Okay. And it's just a matter of getting accustomed to working with fractions. Okay. Let's do this one. Why don't you do this one?
Thank you.
Okay.
All right. Remember, asymptotes, start with those first and then start plotting through. As you start to plot these things out, and it's a little trick here. As soon as you start to plot it out, you know where your asymptotes are going to be at. You know you're going to have a horizontal asymptote at y equals 1/2, and a vertical asymptote at, what is that, x equals 2? Y. Make sure you label it, okay? So I know right away that the couple of numbers to the left, I'm going to choose at 1 and 0. And the ones on the right, I'm going to go with 3 and 4. Yes, sir?
I'm so confused on how you do the horizontal.
The vertical asymptote's always the 0 of the denominator. What can't x be? In this case here, if I said 2x minus 4 equal to 0, solve for x, I add 4 divided by 2, and I get 2. If x equals 2, I get 0 in the denominator. Bad things, bad things. So that's why it's a vertical asymptote at 2. The horizontal asymptote occurs when you have them set up where this looks like it's a linear over a linear, like this, where basically when the degrees are the same. It's always the coefficients of the leading term as a fraction. So in this case, since it's x plus 1 over 2x minus 4, the leading term coefficient of the numerator is 1. So I get 1. Those are the rules for these things here. The rules for the asymptotes when they look like that, when they have the same degree top and bottom, are as that. Just like what we're doing here. We have that same degree. It's the fractional coefficients, and then it's the zero denominator. Always be a vertical asymptote. No matter what, it will always be the vertical asymptote. But did you see how I did that there, guys? I automatically knew the 4 points I was going to check because I'm just bouncing to the right and to the left of my asymptote. And that's usually the easiest way to help make some things work. Now, I'm not going to lie. There are times that secondary point might give you a really crummy value. Sometimes as you start to work through it, you might start to pick up on that it's easier to pick a different number, and that's fine. But this is a general idea of how to set it up, okay? So if you used 1, you get 2 in the numerator and -2 in the denominator. So you get -1. If I use 0, I get -1/4. If I use 3, I get 4/2, which is
2.
not a half.
That's what I did.
And if I use 4, I get 5 in the numerator, and what is that? 4 in the denominator, so it's 5/4. Okay. And it's just a matter of plotting them out then. So at 1, we were at -1. 0, -4, so it's working its way up. So it's doing this. At 3 and 2, 4 and 5/4, so it's doing this thing. Not too shabby?
Not too
Not too
shabby.
shabby, neighbor.
All right. Let me give you a few of these to work on for tonight. And we'll go into a little bit more of the trickier versions tomorrow. So let's see, this is 9.2, it's on page 543. I'd like to do numbers 12 through 18. That's just where are your asymptotes and your domain range.
Basically what we just did.
And then the graphing part will be, let's see, 24 to 38 evens. That gives you what? 4 of each style. 4 of the AH and K and 4 of this guy. Okay? A domain and range. So, yeah, you'll be doing domain and range for all. So get in the habit of stating your domain and range for all of this stuff here as well. It's pretty simple. What's up? Domain and range. Remember your domain and range, what's restricted on your vertical for a domain, what's restricted horizontal for your range. Okay. Yeah, it's all, oh, I forgot to write down, my bad. Yeah, this is also evens. It's just identifying the asymptotes. All this stuff is, the 12 through 18 is just what are the asymptotes given the function, so you can get your H and K. And then the other ones are just graphing it. I don't want you guys to use graph paper on these things. I want you to draw it in, label your parts, and go off of that. Because I think it's going to be a little, it winds up being a little bit more, I don't want to say onus to you, but you're going to own it a little bit better if you know what the values and the points you're using to start with, because it's easier to visualize. Okay? Preguntas?
Sure.
No.
Good.
I don't know what that is.